In January 2022, something extraordinary happened beneath the waves of the South Pacific. The Hunga Tonga-Hunga Ha'apai volcano erupted with a force that scientists are still trying to comprehend. This wasn't just any eruption. It was an underwater volcanic explosion that would challenge everything we thought we knew about how volcanoes affect our climate. When volcanoes on land erupt, like Mount Pinatubo in 1991, we can see their impact clearly. Ash clouds block the sun, sulfur dioxide forms cooling aerosols, and global temperatures drop. But underwater volcanoes, they were considered minor players in the climate game. The Hunga eruption changed that perspective entirely. Initially, scientists looked at satellite data and saw surprisingly little sulfur dioxide released. This led many to believe that Hunga's climate impact would be minimal. They couldn't have been more wrong. What made this eruption unique wasn't what it sent into the air, but how much water it blasted into the sky. In just 1 hour, Hunga injected an estimated 3 billion tons of water vapor high into the atmosphere. That's enough water to fill more than 1 million Olympic swimming pools, shot directly into the stratosphere and mesosphere, layers of our atmosphere rarely touched by Earth's surface processes. While land volcanoes primarily cool the planet through sulfur emissions, this underwater giant took a different approach. The massive amounts of water vapor reached heights in our atmosphere where such moisture rarely exists, creating atmospheric changes that scientists are still tracking today. But what about the sulfur? The magma deep below Hunga was actually rich in sulfur. But here's the fascinating part. Over 93% of it never reached the air. When the magma exploded between 400 and 1,000 meters below sea level, most of the sulfur dissolved directly into the ocean. Scientists estimate a total of 9.4 teragrams of sulfur was released, but almost all of it bypassed the atmosphere entirely. This means our traditional monitoring tools missed the true scale of the event. The sulfur was there. It just took an unexpected path. The eruption wasn't just powerful, it was incredibly fast. Magma surged from deep reservoirs to the ocean floor in under 3 minutes, preserving microscopic chemical features that tell us about the complex processes happening just before the blast. Over its 11-hour duration, the eruption released enormous amounts of magmatic water. Yet remarkably, less than 10% of the total water vapor came from the magma itself. The vast majority resulted from seawater instantly flashing into steam when it contacted the superheated magma, enough steam to fundamentally alter the sky above. This eruption has forced scientists to rethink volcanic climate influence. Without visible sulfur clouds or clear atmospheric signatures, how many similar eruptions have we missed throughout history? How many climate shifts have we misattributed? The Hunga eruption has proven that water vapor alone can drive significant climate shifts. It's demonstrated that submarine volcanoes deserve far more attention than they've received in climate science. Studies now show measurable cooling across the Southern Hemisphere linked directly to this event, along with other atmospheric changes we're still discovering. Beyond climate, the eruption highlighted other dangers. Submarine explosions can trigger massive tsunamis, damage undersea communication cables, and reshape coastal environments. Researchers from the University of Auckland and their Tongan partners continue to study these effects, helping Pacific nations prepare for future events. The Hunga Tonga-Hunga Ha'apai eruption has done more than shake the ocean floor, it has shaken the very foundations of climate science. It showed that the deep sea holds more than mysteries. It contains forces powerful enough to reshape our atmosphere and alter global temperatures. As we continue to explore Hunga's aftermath, one thing becomes clear. We've been reading Earth's climate story with significant chapters missing. The underwater worlds we've overlooked may hold the key to understanding our planet's past climate shifts and predicting its future. This is the legacy of Hunga, a submarine volcano that erupted from the depths to rewrite what we know about our atmosphere, our climate, and ultimately our planet's delicate balance. For more on this story, find a link to the article on Earth.com in the description.